Let's take a look at problems from section 5.5 homework on exponential and logarithmic equations and inequalities. The first problem here is to use a graph to find the solution set of the following: f of x is equal to 0 and f of x is less than 0. So they're giving us a picture of 4 to the x minus 5 as our function. So we're trying to find where 4 to the x minus 5 is equal to 0, or another way to think about this is where 4 to the x is equal to 5, and using the x-intercept method. So also keep in mind there is a horizontal asymptote down here, but we don't even really need to be concerned with that. The thing we need to know is the 0. Our 0 is 1.160964. So we're trying to find the solution of that first equation. Well, that solution is exactly the x value, that is the 0. So 1.160964. Now part B would say to find where f of x is less than 0. So there we're trying to find where 4 to the x minus 5 is less than 0, or where 4 to the x is less than 5. Well, 4 to the x minus 5 is less than 0. We can use that since that's a graph that we're given. It's less than 0 where it is below, right? Where it is below the x-axis, and it's below there. So that occurs to the left of 1.16094. So our solution is 1.16094. Oops, that's not right. Y'all should stop me. If you were in class, you would be raising your hand. I'm sorry, I mean negative infinity to 1.16094. Okay. Number 2 is to solve for x and to give an exact answer. Here is an exponential equation of type 2. We cannot convert 2 and 31 into a common base, so we would have to use logs. So we would take the log of 2 to the x, and that's equal to the log of 31. So therefore we get x times log 2 is equal to the log of 31. So to solve for x, we would divide both sides by log 2 to get log 31 over log 2. And so that is our exact answer, which would be part A. Part B, 5 to the x plus 2 equals 6 to the x. Again, we have to take the log of both sides, and so we would get the log of 5 to the x plus 2 is equal to the log of 6 to the x. So we have x plus 2 times log 5 is equal to x times log 6. Okay, so that key property that log of x to the r is equal to r times log x is coming into play. So we want to get everything with x on the side by itself, so we need to remove parentheses. So we have x times log 5 plus 2 times log 5 is equal to x times log 6. So we would subtract the x log 5 from both sides. It doesn't really matter which direction you go, but since we already have an x term on the right by itself, we can move the other x term over with that. So in doing that, we would get 2 log 5 is equal to x log 6 minus x log 5. And then a key way to get the x's out is to factor. And so if we factor out an x, we would have 2 log 5 is equal to x times log 6 minus log 5. Now don't be creative and try to combine those to be log 1, right? I can't subtract inside the logs. If anything, log 6 minus log 5 is a log of 6 over 5. But now I need to get the x by itself so I can divide by that coefficient. So I'd have 2 log 5 over log 6 minus log 5. and that's equal to x. Okay. Now, if you needed to use your calculator and approximate that, we could. We would have 2 times log 5, close parentheses, divided by, in parentheses, log 6 minus log 5. And you should get roughly 17.65 for x. And how can you check, right? Any equation you can check. If we go back and plug in the 17.65, we should get roughly the left side equal to the right side. We rounded off, so we're going to have a little bit of an error with rounding, but it should be very close. Now, going into some log equations, log base 10 of 6x minus 2 equals 4. Now that MyMathLab puts in that base 10. You don't really need that, but that's okay. It helps remind us that this is equivalent to 10 to the 4th power is equal to what? Yeah, 6x minus 2. So to solve a log equation, we need to convert it to an exponent if we have a single log on one side. Now, 10 to the 4th. Why did they do that? That's the one drawback with MyMathLab. Some of these numbers can get really large. That's 10,000 is equal to 6x minus 2. So we can add 2 to get 10,002 is equal to 6x, and now divide by 6. So 10,002 divided by 6 does simplify nicely to be just 1667. Now, log x plus log of x plus 21 equals 2. So in this case, I need to combine the logs on the left side. So a sum of logs is a log of a product. So this is the log of x times x plus 21 is equal to 2. So converting this to the exponential form, understand that we have a log base 10. So this means 10 squared, or 100, is equal to x times x plus 21. So we'd have to get this equal to 0 and solve it. So I'm going to do that in one step. We're going to go ahead and multiply this out and subtract 100. So we would have 0 is equal to x squared plus 21x minus 100. So now, do you remember what to do? We got a factor. Right, and you got to find the factors of 100, whose difference is 21. You know what those would be? The factors of 100 whose difference is 21 would be, 25 and 4. And we need plus on the 25, minus on the 4. So we get then that x is equal to negative 25, or x is equal to 4. Now if you just go on your way and put in negative 25 and 4, you're going to be wrong. Do you remember why? Yeah, you cannot have a negative value inside the log. So if you put in the negative 25, that's going to make that negative. So we have to throw out, that negative 25. So our only solution would be 4. And here's another thing I really don't like about MyMathLab, that they vary between when they have brackets and when they have x equals. X equals, you're just going to put in the number. If it has brackets, you would put just the number inside there. Okay. Now we have log base 2 of x plus 7 plus log base 2 of x minus 7 is equal to 5. Very similar to the last problem. We need to combine logs to write this as log base 2 of the product x plus 7 times x minus 7, and that's equal to 5. So therefore we get 2 to the 5th power is equal to the product x plus 7 times x minus 7, which is actually x squared minus 49, right? That's a plus b times a minus b is the difference of two squares. So 2 to the 5th is 32 is equal to x squared minus 49. So now we can add 49 to both sides to get, what is that, 81 is equal to x squared. So x is equal to plus or minus 9. Now here again, we can't just go on our way and put 9 and negative 9 and think we have it right. We've got to make sure that those numbers don't make the inner expression negative. And if you put in a negative 9, you can see that you would get a negative in both logs, so we have to discard that. Log base 5x plus log base 5 of x plus 1 equals log base 5 of 2. Now notice this one is slightly different, right? It's got logs on each side. So once we convert the logs on the left, log base 5 of x times x plus 1 equals log base 5 of 2. We can use the one-to-one property of logs that says log A equals log B means that A has to equal B, right? The log passes a horizontal line test, so the only way for two logs to be equal is if their inputs are the same. So this would mean that x times x plus 1 has to equal 2. Okay, so we get x squared plus x. We subtract 2 equals 0. So the factors of 2, whose difference is 1, would be 2 and 1. We need a plus on the larger or minus on the smaller. So this time we get x to be negative 2 or positive 1. And here again we can't have a negative inside the log, so we have to throw out the negative 2 and only use the 1. Just a few more problems. The natural log of e to the x minus the natural log of e to the 8th is equal to the natural log of e to the 9th. So what I would need to do, convert this on the left to be the natural log of e to the x over, well, there's actually a couple ways you could do this problem, but I'll show you the other way. The natural log of e to the 8th, so since we're subtracting logs, we can make the log of the quotient. Okay, so the natural log of e to the x over e to the 8th is equal to the natural log of e to the 9th. So here we know that that's really what? E to the x over e to the 8 has to equal e to the 9 because we have natural logs on both sides, so we can just set their inner expressions equal to one another. Well, e to the x over e to the 8th is the same thing as e to the x minus 8, right? When you divide like bases, you can subtract. And so we get e to the x minus 8 is equal to e to the 9th. So therefore, by properties of the exponent, we have that x minus 8 has to equal 9. So x is 17. Now, if I was really paying attention, I wouldn't have gone through all of that process. The other way to do it, natural log of e to the x is simply what? Yeah, it's x. Minus natural log of e to the 8th, it's 8, is equal to natural log of e to the 9th is 9. So I get that right away to find that e, or rather x, is 17. That's because natural log and e have the same base, so they are inverses of each other. Now, this problem here is to solve the formula log b equals log f minus n times log x for b. So we need to rewrite this as what? Log b is equal to the log f minus log of x to the n, right? To get rid of the coefficient, we did those in an earlier section just using properties of logs to rewrite. And now we can rewrite this as log of b is equal to the log of, how do we convert the quotient, or I told you, I'm sorry, the difference of logs is the log of a quotient, so this would be the log of f over x to the n. Now, by virtue that log is 1 to 1, what this means, if the log of b is equal to the log of f over x to the n, their inner expressions are equal, so b has to equal f over x to the n, which is part b. And the last problem that I wanted to show you is to find the approximate solution to the equation by graphing the appropriate functions on the graphing calculator. X squared equals 1.9 to the x. We have no algebraic way, believe it or not, to solve something of the form x squared equals 1.9 to the x. We have to do it with a graphing calculator. So what you would have to do is on the graphing calculator, in your y equals, oh no, my battery's about to die. let me save this one for the graphing calculator screen, and I'll change my batteries and I'll put this one up. But this one will be for the graphing calculator video, and I'll show you how you can do that. Okay, so that concludes the homework from this section. If you have any questions, don't hesitate to contact me. Thanks.